Hi, integrated science students. Today's video is going to be relatively short. We're only going to cover pyroclastic material. The last one we watched, hopefully you watched, covered lava by flow type. There's lava by composition. I think at this point you probably understand that the amount of silica is a huge player in the type of lava and the type of flow that we get. But lava flow only results from non-explosive eruptions. But when we're talking about explosive eruptions, we don't get lava, we get pyroclastic material because the explosions are so violent that the lava is thrown into the air. It doesn't flow over the side, it's thrown way into the air. And while it's up there, it hardens. And some of it comes right back down because of its size. Some of it, like the ash, can float around a really long ways. So let me share my screen with you. Again, you're just going to take the notes that you have been taking on volcanoes, and we're going to add to it. So again, just really quickly, the last thing we saw was this lava by flow type. You should know all of these little bullets about each type, the the pahoehoe, the pillow, and the blocky. And when we get into pyroclastic material, let's get started. So again, pyroclastic material is going to come from explosive eruptions, not the non-explosive. Remember, and we're going to get into types of volcanoes as well, but remember that a composite volcano or a stratovolcano alternates between explosive and non-explosive. And a lot of times you'll get the initial explosive, and then since that pressure's been released, then we get the lava flow. And the depth of it, of each layer, is going to vary from volcano to volcano. Basically, pyroclastic material is formed when magma explodes from a vent and solidifies in the air. That is one main source. That's probably the greatest source. But also with really powerful eruptions, existing rock, maybe it's that plug that's plugging up the vent. The reason that we had an explosive eruption to begin with, because all that pressure was building up and that plug was holding it in there like a cork that you've really smash down into a bottle. If you really smash it down in there, it takes a lot more force to get it out. So if we have exceptionally violent eruptions and we have existing rock, and we will existing rock around the vent or the crater, that then it's already hardened on the mountain or on the volcano, but that can turn into pyroclastic material as well, just by being shattered from the explosion. Of course, science can't just say, pyroclastic material, great. No, we have to classify it. This one's easy to classify. It's all classified by the size, and there are some giant pieces of pyroclastic material that can result. And again, it's going to depend on how explosive the eruption is. Volcanic blocks, they're the largest of the pyroclastic material. I brought a little prop here so that I could give you an idea of the size. It's anything greater than 64 millimeters. Okay, so how big is 64 millimeters? Do we even understand how big? I know we're not really good with the metric system, right? 64 centimeters would be about as tall as this ring stand. I'm holding it this way because it's a long way, but anyway, that's about, but we're talking about 64 millimeters. Yeah, millimeters. So that is from my finger to the end. Anything bigger than that, that's 64 millimeters, because that's 6.4 centimeters. Okay, metric system, remember? You guys remember the epic metric estimation day of science when you were freshmen and nobody cared to estimate within the metric system until I started giving you food if you estimated correctly. And I think if I remember when you guys were freshmen, Claire Peterson pretty much won all the food. But anyway, 6.4 centimeters is 64 millimeters. Any size of hardened magma larger than that would be considered a block. Now, they can be huge. They, like I said, they can be as big as cars, but anything bigger than that is a block. Volcanic bombs are also, they're smaller than 64 centimeters. They can be, but there's something that makes a bomb unique, and I'll show you on the next page. It's a blob that gets expelled into the air, blown into the air, and it's spinning as it hardens. And I'll show you on the next page that unique shape that results from a bomb. The spinning, you can imagine the centrifugal force would cause it to get these little tails on it, but I'll show you in a minute. It's the example that I have is larger than 64 millimeters, so it would be, in a way, it would be considered a block because it's larger than 64 millimeters, but the fact that it has the little tips on it would make it just a really large volcanic bomb. I won't expect you to know the difference there. I just want to show you what it looks like. I used to have an actual little volcanic bomb and I lost it, much like my marbles. Lapilli, which means little stones in Italian. The reason that there's a lot of different Italian words that describe volcanoes is Italy has a lot of volcanoes. It's on that ring of fire. But 2 to 64 millimeters is going to be considered lapilli. I'm trying to think of something at school that would be like this, but 2 to 64, so we're going to have millimeters from my finger to the end. That's 2 millimeters. So they can get pretty small and fairly larger. But again, the bomb is, it's got to be a certain size, but it's the shape, these bombs. So next we have volcanic ash. The walls, this comes from, we have these gas bubbles. Remember that trapped gas in magma is one of the things that causes it to be an explosive eruption. Remember, we've got trapped silica, trapped water, and trapped gases are the three things that, not trapped silica, but high content silica, are going to be the three things that contribute to an explosive eruption. And so when these gas bubbles, they form, and then when they explode, the walls of that bubble, which had hardened, turn into these tiny little bits of, and there's a lot of silica in there. It's just like breathing glass, I've been told. And so it makes up most of the pyroclastic material. That's the stuff that traveled all the way from Mount St. Helens in 1980 in Western Washington to Eastern Washington, where I was out in the middle of a wheat field pulling rye when I heard it. And then when I got home, we just had a dusting at my house, but some places in Central Washington got just dumped on Ritzville. It was awful. My aunt lived there. So anyway, so anything less than 2 millimeters is going to be considered ash. We're going to have a fine line between 2 millimeters. Is it lapilli? Is it ash? Normally the ash is able to stay up in the atmosphere longer. Let me give you some picture examples. And again, this is a short video that we're doing. Obviously ash. I'd wet my pants if I was anywhere near that. Then we've got, this is a very wide range. All of this stuff came down from an explosive eruption. So we've got these huge blocks. We've got lapilli out here. We've got, I mean, this is all types of pyroclastic material in all sizes. The ash is since gone because this was long after the explosion. This is examples of lapilli. And then you will also see these tiny little holes in there. Those are those gas bubbles. As those explode, that's what turned into the ash. And it's large, but this is what I was talking about on the volcanic bomb. You can see these little wings on the end. As this was spinning, centrifugal motion, when something's spinning, there's a force moving away from the center. And when it was liquid, it was able to stretch because it was spinning, but then it finally hardened and you get these cool little tips on the end. And giant, obviously. These would be blocks. These are larger than 64 millimeters. And I wish that I knew what volcanic eruptions these are from, but I don't. But anyway, today's quiz is going to be over pyroclastic material, so hopefully you watch this. Some of you, I can still tell, are trying to take the quizzes without watching the video, and some of you never watched the video on the volcano parts because I got questions clear through Saturday. Well, what was our assignment this week? It's at the end of the video, okay? So anyway, your assignment for this week, are you ready? Are you ready for your assignment? I'm giving it to you, all right? Your assignment for this week is I want you to choose a volcano that you would want to do some research on. And I want it to be, this is going to sound kind of morbid, but I want you, hopefully it'll be a deadly one. Like you can search deadliest volcanic eruption, United States, deadliest volcanic eruption, Italy, deadliest volcanic eruption, Chile. Look at some of the volcanoes that we did our research on, and it can be from that list, I don't care. But look at some of the countries that those were from, and I want you to search deadliest volcanic eruption of, and then name the country. And I'm going to assign you some research on a specific volcano, but I'm going to assign those people that email me their top 3 volcanoes from any country that they would like to do research on. The first person to email me gets their first pick. And anyway, so that's your homework. Hopefully you watched the video. So your homework, again, let me just repeat, email me, jketterling@parmaschools.org, the top 3 choices that you would want if you were going to do a research paper on a volcano. I want you to search it as deadliest volcano of, and then put in the country. Give me your top 3, and then I will be letting you know what volcano you're going to research and what needs to be in the paper. So I see you guys on the other side. Oh, and don't forget, I'm actually filming this on Mother's Day. I hope you guys told your mom Happy Mother's Day. Moms are pretty awesome.